Hello everyone, this is Sedi and welcome to Sedi's Mathverse. For today's video, we will discuss perfect square trinomials, which is a topic in grades 8 and 9. In this video, we will learn how to construct a perfect square trinomial given some terms. Without further ado, let's get started. First, what is a perfect square trinomial? A perfect square trinomial is a trinomial of the form ax squared plus bx plus c, where x is the variable and a, b, c are the constants. However, it is more than that. These constants satisfy the relation b squared equals 4ac. What are the examples of perfect square trinomials? We have 9x squared minus 6x plus 1. A property of a perfect square trinomial is it can be factored into a square of a binomial, which is something that I have discussed in the special products video. This one can be factored into quantity 3x minus 1 squared. Another thing, or another example, we have x squared plus 8x plus 16. This can be factored out as quantity x plus 4 squared. Basically, perfect square trinomials are trinomials which can be factored into a square binomial. But how do we find missing terms of a certain expression such that the whole expression is a perfect square trinomial? We will find out in the next part. Remember the other definition of perfect square trinomial? We said that the constants of ax squared plus bx plus c satisfy the relation b squared equals 4ac. This is derived from the fact that the discriminant must be 0 for it to have the same root. Remember the quadratic formula x equals negative b plus or minus b squared minus 4ac all over 2a? This formula is indeed the key into determining which quadratic expressions are perfect square trinomials. If this expression is 0, then this reduces to just negative b over 2a, which means that there's exactly one root and the whole expression is a perfect square trinomial since they have two identical roots. And that is the other definition of a perfect square trinomial, right? This can be expressed as a square of a binomial. Now let us not add more definitions and proceed with an example problem. Complete the perfect square trinomial t squared minus 8t plus blank. Alright, we will utilize the fact that b squared equals 4ac to solve for the c term. Remember that the missing term is the c. So we let this one as c, and we know that the a term or the quadratic coefficient is 1, then the b term is negative 8. This gives us negative 8 squared equals 4 times the first term, the quadratic coefficient rather, 1, then c. As we can see, the substitution from this generalized formula to this equation. So we have negative 8 quantity squared, which means that this is 64 equals 4 times 1 is 4 times c is 4c. Finally, dividing both sides by 4 gives us c equals 64 over 4, which when simplified is 16. Alright, let's have problem 1. Find the value of k such that kx squared plus 14x plus 1 is a perfect square trinomial. Alright, remember we have a equals k, b equals 14, and c equals 1. Using the fact that b squared equals 4ac, we get k squared, 14 squared rather, equals 4 times k times 1. Then 14 squared, when we simplify it, it becomes 196, which is equal to 4 times 1 is 4 times k. Then dividing both sides by 4 gives us k equals 49. This means that our correct answer is 49. Alright, here's problem 2. Find the value of c such that 4x squared plus cx plus 49 is a perfect square trinomial. We will do the usual thing. We have b squared equals 4ac, which means that b equals c. So we have c squared equals 4 times the a, the quadratic coefficient, 4. Then we have c, which is 49. Then we simplify it. So we get 784 as the right-hand side. Taking the square root of both sides, we get c equals, since this is an equation, we consider two roots, positive and negative 28. And you can see that both of them works, which means that our solutions or the answers for our problem is c equals 28 and negative 20. Alright, now here's our last problem for this tutorial. What value of p makes quantity p minus 1x squared plus quantity 2p plus 4 multiplied by x plus p plus 6 a perfect square trinomial? This looks like a little complicated, but it's still the same process. We have a equals p minus 1, b equals 2p plus 4, and c equals p plus 6. Then we have b squared equals 4ac. So we have 2p plus 4, quantity squared, equals 4 multiplied by p minus 1 multiplied by quantity p plus 6. Expanding these two expressions gives us 4p squared plus 16p plus 16 equals 4p squared plus 20p minus 24. Then, we get to cancel these two, and then we move the constant here at the right hand side and the linear terms at the left hand side. 16p minus 20p equals negative 24 minus 16. This becomes alright, this equation becomes negative 4p equals negative 40, in which when we divide both sides by negative 4, we get p equals 10, which is the only value of p that satisfies the given condition. That is it for today's video, ka-Mathverse. I hope you learned something and enjoyed this video. If you did, subscribe to our official YouTube channel and follow our social media accounts whose links are shown here. That is it, guys. And remember that mathematics is incomplete without you, and chase your greatest moonbeams. Till next time.